All right, we've talked about our vertical asymptotes, and now we're going to talk about finding our horizontal asymptotes as well. Remember that vertical asymptotes are always in equation form, x equals some number. Horizontal asymptotes, because they represent horizontal lines, will be in the form y equals some number. So our horizontal asymptotes will always be in the form y equals a. So for example, y equals 2, y equals -10, whatever that value happens to be. Okay, so looking at the graph for number 3, it says we can identify horizontal asymptotes if you look at the far left side and the far right side of the graph, otherwise known as the tail ends of the graph. So just visually, can we guess what the horizontal asymptote is for each graph? All right, so looking at this graph on the left, as I go to the far left of my graph, I can see that my graph is kind of petering out, and it looks like it's leveling off around a height of maybe 2, and then same thing as I go out to the right. Okay, so I'm going to represent this with a dashed horizontal line, and my assumption looking at the graph is that the horizontal asymptote for this graph would be y equals 2. And we'll verify this algebraically in just a moment. Looking at the graph on the right, so again, looking at the far left and the far right side, so I'm kind of ignoring this central portion just for horizontal asymptote purposes. So I'm just looking at the graph way out here and way out here, right? And I can see that in both cases, it's skating along that x-axis. So it looks like there's a horizontal asymptote right here along the x-axis, which would be my horizontal asymptote y equals 0. So horizontal asymptote y equals 0. So these are my predictions based on my graphs, and like I said, we'll verify this looking at the actual equation in just a moment. I also want to point out that in the graph on the left, my graph does not cross my horizontal asymptote y equals 2. So the graph does not cross my horizontal asymptote. I'm going to call it HA, horizontal asymptote y equals 2. But if I look at my graph on the right, I can see right here at the origin, 0, 0, it looks like my graph passes through the origin, which means that my graph does cross. So my graph crosses the horizontal asymptote y equals 0. So remember, with vertical asymptotes, our graph could never cross a vertical asymptote, but with horizontal asymptotes, sometimes your graph will cross it, sometimes your graph won't cross it. So in the center of the graph, like this region here, you could see your graph crossing through that horizontal asymptote, but toward the extremes of the graph, the extreme left and the extreme right, that's where it's going to level off and not cross the horizontal asymptote. So I just want to mention that. Okay, so let's look at our rules for selecting our horizontal asymptote. So down here at the table at the bottom of the page, it says that we're focusing on the degree of the numerator and the degree of the denominator. So these degrees come from our exponents in the numerator and denominator. The degree of the numerator will be the highest variable exponent that we see, and same for the denominator. The degree of the denominator will be the highest variable exponent that we see. So for our function on the left here, let's look at the numerator. Okay, so the numerator degree equals what? Well, I've got 2 times x to the first power minus 1. I've only got one variable. Its exponent is a 1, so the numerator degree equals 1. In my denominator, I've got x plus 2. That's x to the first power plus 2. So the denominator degree, again, equals 1 from that exponent 1. All right, so let's see what case we have here. In our table, that's the second case here, where it says the degree of the numerator equals the degree of the denominator 1 equals 1 in this case. So then for our horizontal asymptote, y equals the ratio of the two lead coefficients, So here's our two leading terms. The leading coefficients would be 2 and then 1 in front of that x. So y equals 2 over 1, coefficient over coefficient, which simplifies to y equals 2 for that horizontal asymptote. So when the degree of the numerator and denominator match, when they're equal, if they're both 1, if they're both 5, if they're both 2, that means you take a ratio of the leading coefficients. And that's the number that appears in your horizontal asymptote. All right, scooting over to this graph to the right, looking at our function. So the degree of the numerator and denominator, starting with the numerator, 2x to the first power. So the numerator, I'm just going to put numerator degree equals 1. And in the denominator, we have x squared minus 4. So the denominator, I'm just going to put den, denominator degree equals 2. So that brings us to this first case, right? The degree of the numerator is less than the degree of the denominator. Sometimes I refer to these as bottom-heavy functions. So the degree is larger on the bottom, larger in the denominator than it is up in the numerator. The 2 degree is bigger than the 1 degree up top. So that means that we'll end up with a horizontal asymptote y equals 0. And that's what we got before, so this is verification. Y equals 0 is the horizontal asymptote. And the reason for this is as x gets bigger and bigger and bigger, so we can just think about positive numbers, although it's also true for extremely large negative numbers. If I have, f of 10, f of 1,000, f of 1,000,000, f of 1,000,000,000, as x gets really, really, really big, x squared is going to get super, super duper big much faster than just plain old x. So because the degree is higher, when I square 1,000,000,000,000, that's going to be way bigger than 1,000,000,000,000 up in the numerator. So as these numbers get huger and huger and huger, like infinitesimally large, that denominator is going to completely overtake the numerator. And we're never going to equal 0, but we're going to get really, really close to 0 for our function value. Okay, and by the way, there's a third case where the degree of the numerator is greater than the degree of the denominator. And in this case, we just say there's no horizontal asymptote. There's also something called a slant asymptote. So that exists, but we're not going to cover it in this course. But they do talk about it in the textbook. So if you're curious, do a search on slant asymptote. And that's a diagonal asymptote that you could also see in your functions. But for us, we're not going to go that far. So you'll probably see that in future math courses. Okay, and quickly, one more thing that I want to mention just about finding the degree. If we had y equals 2 over x to the 4th plus 5 or something like that, the denominator degree would be 4 from that highest power exponent. And the numerator, since there is no variable, the degree would be 0. So the numerator degree would be 0. So you can have a 0 degree if there's just a constant. And by the way, let me just add this in. Even if we had x to the 4th plus 5x in the denominator, we'd still have a degree 4 denominator. So it's just the highest power that appears. Okay, so moving on to number 4, it asks us to complete the table. So they ask us for the different degrees and then for the horizontal asymptote. So for the graph on the left, f of x equals negative 4x over x squared minus 1. The numerator degree would be 1. The denominator degree would be 2. And because the denominator's degree is bigger than the numerator's, or the numerator's degree is less than the denominator's, this is one of those bottom-heavy functions. So my horizontal asymptote will be y equals 0. So that would be this case in the table right there. All right, and my function on the right, f of x equals negative 4x squared over x squared minus 1. Degree of my numerator is 2. Degree of my denominator is also 2. Because the degrees are equal, this is where I'm going to take the ratio of the leading coefficients. So that's going to be a negative 4 up in the numerator. And then in the denominator, I don't have a visible coefficient, but it's a 1. So that 1 is going to be in my ratio. So my horizontal asymptote will be equal to y equals negative 4 in the numerator over positive 1 in the denominator. So that gives me y equals negative 4 when I simplify. So that's my horizontal asymptote. All right, and then looking at number 5, we want to find the vertical and horizontal asymptotes of each function, if they exist. And sorry about the typo, this is supposed to say equals, and this is supposed to say equals there. All right, so for A, f of x equals 3x minus 6 over x minus 5. So remember with your vertical asymptote, you're setting your denominator equal to 0 and solving for x. So for my vertical asymptote, I would set x minus 5 equal to 0 and solve to get x equals 5. So that's my single vertical asymptote. Then for my horizontal asymptote, I look at the degree of the numerator, which is 1, the degree of the denominator, which would also be 1. The degrees are equal, so I'm going to have a ratio of the leading coefficients. So I'm going to have y equals 3 over 1, which gives me y equals 3 after simplifying. All right, vertical asymptote for part B, f of x equals negative 3 over x squared minus 3x. For my vertical asymptote, I'm going to take just the denominator, x squared minus 3x, and set it equal to 0. I can factor to solve, so I get x times x minus 3 equals 0. And then I set each factor equal to 0, so x equals 0, so that's one vertical asymptote. And x minus 3 equals 0. When I solve that, that gives me x equals positive 3 for my second vertical asymptote. For my horizontal asymptote, the degree of the numerator is 0 because I just have a constant up in the numerator. And in my denominator, I have a 2 exponent and a 1 exponent. So the degree of my denominator is 2. The degree in the denominator is larger. This is a bottom-heavy function. So that gives me my horizontal asymptote y equals 0. All right, C, f of x equals 1 minus 3x squared over x squared minus 5x minus 14. For my vertical asymptote, I'll set that denominator equal to 0. So set the denominator equal to 0, factor to solve. So that would give me x minus 7 times x plus 2 equals 0. Then set each factor equal to 0. If x minus 7 equals 0, then x equals 7. If x plus 2 equals 0, then x equals negative 2. So those would be my two vertical asymptotes. And then for my horizontal asymptote, I'm going to look for my degrees. Degree 2 in the numerator and degree 2 in the denominator. Because the degrees are equal, I'm going to set y equal to the ratio of the leading coefficients. My leading coefficients are negative 3 in the numerator and a 1 from that x squared term in the denominator. So y equals negative 3 when I simplify. And finally, for my vertical asymptote, I'm going to take x squared plus 1 equal to 0. That's my denominator. So be really careful here. This isn't a difference of two squares because I have a sum plus instead of a difference. You could try subtracting 1 from each side. This would give you x squared equals negative 1. And then when I take the square root of both sides, putting in my plus or minus, this would actually give me x equals plus or minus my imaginary unit I. Vertical asymptotes have to be set equal to real numbers. So we don't have a vertical asymptote in this case. Our denominator can't equal 0 from any real numbers anyway. So there's no real number that creates a 0 in the denominator. So we don't have any vertical asymptotes because we have this imaginary solution. And for the horizontal asymptote, degree 2 in the numerator, degree 2 in the denominator. So my leading coefficients, y equals 5 over 1, which is simplified to y equals 5.